Right, let's dive straight in. We're tackling the mind-body problem, but not just any way. The text kicks off by saying the very first, most crucial step is nailing down exactly what we're trying to solve. It's like trying to fix a leaky faucet without knowing if it's the tap, the pipe, or the water pressure causing the issue. We've all heard the classic questions. What is the mind? How does it relate to the body? Fair enough, they point us in a direction. But honestly, they're a bit vague, aren't they? Like asking, how do cars and roads interact? Without specifying whether you mean traffic flow, road construction, or fuel efficiency. Before we can even begin to talk about how mental events connect to physical ones, we need crystal clear definitions of what counts as a mental event versus a physical one. That's the real hurdle here. So, how do we make this less abstract? The author suggests zooming in on something more concrete. Think about the signals buzzing around in our nervous system, those physiological impulses. The core idea is to figure out how these different signals, originating from various parts of the brain and nerves, manage to create distinct experiences. Red looks different from blue, loud sounds different from soft ones, right? We know that. The challenge is to show that the relationships between these different nerve pixels mirror the relationships between the different colors or sounds we experience. It's about establishing a direct link, a correspondence, proving that the functional differences in the brain's wiring correspond precisely to the qualitative differences in our conscious experience. It's like saying the unique electrical patterns for red light in the visual cortex have the same relationship to each other as the concept of red has to the concept of blue in our minds. Why focus on sensory qualities specifically? Well, the argument is that this is where the rubber meets the road for understanding all mental phenomena. Sensory qualities, color, pitch, texture, smell, are the building blocks of our entire experiential world. They seem fundamentally different from mere physical properties like mass or velocity. By figuring out what determines the order of these sensory qualities, why red is red and blue is blue, not the other way around, we might crack the code for understanding the nature of all mental events. It's like understanding the fundamental particles gives you insight into the whole universe. The claim here is bold. Whatever principle explains why we perceive different wavelengths of light as different colors, that same principle should also explain the unique feel of an emotion, the abstract nature of a concept, or the vividness of an image. It's proposing a unifying theory for the qualitative aspects of consciousness. Okay, let's get precise with our terms. When we say sensory qualities, we're talking about everything that makes one sensation distinct from another. It's not just about the basic whatness of a sensation, like its quality versus its intensity. It includes all those dimensions: hue, saturation, brightness for vision, pitch, loudness, timbre for hearing, sharpness, warmth, texture for touch, and so on. Basically, any attribute we use to differentiate one sensory experience from another falls under this umbrella. Importantly, we're setting this apart from other kinds of mental values, like pleasantness or unpleasantness, affective qualities, or moral judgments. We're focusing purely on the descriptive attributes of the sensory experience itself. And the sensory order is just the systematic arrangement of these qualities, based on how they relate to each other in our experience. Now, here's where it gets really interesting. The text points out a huge divergence. Physics, in its quest to understand the laws of nature, has largely swept sensory qualities under the rug when it comes to describing the external world. Why? Because physics defines things by how they interact with each other, their causal relationships, their predictable behaviors. Think Newton's laws, electromagnetic fields, quantum mechanics. These frameworks don't care about whether a particular force feels like a push or a pull, or looks a certain color. They describe the underlying structure. So we end up with two fundamentally different ways of slicing up reality. On one hand, there's the phenomenon order, the world as it appears to us, rich with colors, sounds, smells, textures. On the other hand, there's the physical order, the world described by science, a complex web of interactions governed by physical laws largely devoid of subjective qualities. It's like having two maps of the same territory drawn by two different surveyors using completely different rough methods and criteria. This divergence isn't accidental, it's historical. Early physics, especially optics and acoustics, did start by studying light and sound as we perceive them. Think Newton's prism splitting white light into colors. But physics evolved. Now physicists define light and sound in terms of wave properties, frequency, wavelength, amplitude, regardless of whether we actually see or hear them. They study visible light and audible sound, yes, but they define these using physical parameters. Crucially, modern physics doesn't stop at perceptible phenomena. It dives into the imperceptible: radio waves, X-rays, gamma rays, electricity, magnetism, all part of the physical order, even though they don't directly translate into familiar sensory qualities. This shift means physics has built a comprehensive, predictive model of the world that operates largely independent of our subjective experience. And here's the kicker. These two orders, the phenomenal and the physical, don't line up neatly. There's no simple one-to-one translation. Just because two things look the same to us doesn't mean they are physically identical in their interactions. Think about ripe bananas and unripe bananas. They might look similar, but they behave differently in terms of taste, smell, and chemical composition. Conversely, two objects might be physically identical twins, yet we could distinguish them perfectly based on subtle differences in appearance, or perhaps even feel. This lack of a perfect biunivocal correspondence is key. It tells us we're dealing with two fundamentally different classification systems for reality. What makes events similar in one system, phenomenic similarity, bears little relation to what makes them similar in the other, physical similarity. So, how do we talk about these two perspectives? The text proposes using phenomenic for the world of sensory experience and physical for the world described by scientific relations. Simple enough, right? Of course, philosophers and scientists have used a whole laundry list of terms: subjective versus objective, sensory versus scientific, perceptual versus geographic, familiar versus constructivist. Sometimes the author will use sensorial interchangeably with phenomenic, especially when talking about the sensory order. Later on, we'll even hear them referred to as the macrocosmos, the large-scale physical world, and the microcosmos, the internal world of experience. The crucial point is that the relationship between these two ways of ordering reality is the central puzzle this work aims to unravel. It's about understanding how these two distinct universes of discourse relate to each other. Now, a big warning sign here. Don't fall into the trap of thinking this phenomenic physical distinction is the same old philosophical battle between appearance and reality. That's a common confusion. The text argues against using real in a way that implies the physical world is somehow more real than our experiences. Instead, the focus shifts. It's not about which world is truly real, but about how events are categorized and related within their own system. Is event X considered similar to event Y in the physical order? Or are they considered similar in the phenomenic order? The question, what is X, only makes sense within a specific order. To ask what a red apple truly is across both orders is problematic. We need to ask, within the physical order, how does this red apple relate to other physical objects? And within the phenomenic order, how does this experience of red relate to other color experiences? Even the mind, ultimately, is seen as part of the physical order, just a very complex subsystem whose precise location and nature remain mysterious. The text digs deeper into this idea of reality. Historically, we contrasted reality with mental illusions, things that fool our senses. But think about correcting an optical illusion. We use other cues, other experiences, to realize the straight lines aren't actually bent. Isn't that similar to how physics works? Physicists find two objects that look identical to us might react differently to other objects, revealing a hidden physical difference. If we make reality depend on passing this kind of physical test, then physics becomes more real than the tangible things we see and touch. Or worse, we might reserve reality for something forever beyond our grasp. The author argues this usage distorts the original meaning of real. So, the recommendation is to ditch the term real in scientific discussions. Let's focus instead on the relationships within each order, the physical relationships and the phenomenal relationships. That's where the explanatory power lies. So this split between the physical and phenomenon orders creates two intertwined problems. First, there's the task assigned to physics, since our naive sensory categories, like wood, metal, glass, don't perfectly predict how things behave, because two pieces of wood might behave differently depending on their internal structure, or two things might look totally different but be made of the same stuff. Physics needs to develop a better classification system based on underlying relationships and interactions. This allows us to predict and explain the physical world accurately. Second, there's the problem handed over to theoretical psychology. Given that physics shows the physical world doesn't map neatly onto our sensory experience, why does the world appear to us the way it does? Why do we perceive these specific qualities, organize them in this particular way? Physics tells us how things work objectively. Psychology needs to explain why we experience them subjectively in the way we do. This is crucial. Physics, by showing that our intuitive categories are often misleading, actually hands psychology a central role. Poor physics, maybe people thought the world looked the way it was. Now we know that's not true. The fact that physical similarity doesn't match perceptual similarity turns the question, why do we see things as we do? From a philosophical curiosity into a legitimate scientific problem. Psychology isn't just trying to describe the physical world, it's trying to explain the unique qualitative experience of that world. Even if we had a complete perfect physics, it would still leave a huge chunk of our experience unexplained, the why and how of our conscious qualia. Physics can tell us about the mechanics of light, but not why it appears red. That's the psychological territory. So what exactly is psychology supposed to explain? Not just introspection, the text clarifies. While introspection is a tool, the goal isn't merely reporting inner feelings. It's about explaining the very fabric of our experiential world, the sensory qualities. These are the aspects of our experience that, despite seeming so real and central to our knowledge of the world, don't feature in the physicist's equations or the chemist's formulas. When we study differences in color, pitch, or texture, we're studying mental events, not physical ones. The text makes a provocative claim. Much of what we think we know about the external world is actually knowledge about our own minds and how they process information. Psychology's job is to bridge that gap to account for the phenomenal aspects of reality that lie outside the scope of the physical sciences. Let's reiterate the core psychological puzzle. It's not just that we have sensory experiences, it's that these experiences form a structured order. Red is different from green, loud from quiet, sweet from sour. This structured phenomenal world isn't just a passive reflection of a pre-existing world out there. Psychology must explain this order. It must account for the aspects of our experience that the physical sciences, however advanced, cannot touch. Physics can give us a partial description of the world as it is, but it leaves the why and how of our specific experience, the qualitative feel of things, hanging. We want more than just correlations between brain states and stimuli. We want to understand the process, the mechanism, by which a physical state out there transforms into a particular conscious scene in here. It's about understanding the generation of experience itself. Since this peculiar phenomenal order only seems to pop up in certain organisms when they interact with the world, the obvious place to look for an explanation is within the organism itself. What special property of us allows us to generate this rich, structured experience? The text hints at the answer early on. It seems to lie in our ability to internally represent or model some of the relationships that exist in the physical world. Our nervous system doesn't just passively receive signals, it actively constructs a representation of the environment, and this construction process is key to generating the structured phenomenal order. It's like our brain is constantly building a dynamic internal simulation of the world, and the way it builds this simulation gives rise to our conscious experience. This sets up a fascinating inversion compared to physics. For physics, the way things appear to us, phenomenomic facts, is the raw data, the starting point. Their goal is to find the underlying physical principles that explain these appearances. But for psychology, the starting point is the established physical world, as understood by physics. The task is to work backwards, Given this physical reality, how does the organism process it to produce the familiar sensory qualities and their order? Psychology must reconstruct the pathway from physical stimulus to phenomenal experience. It needs to demonstrate the logic behind why the senses sometimes lump different physical inputs together, generalization, and sometimes treat similar physical inputs as distinct, discrimination. It's about mapping the transformation process. Before moving forward, let's nail down some key terms, especially stimulus and impulse. A stimulus in this context is an external event, something happening out there, that triggers a response in the nervous system. This could be light hitting the retina, sound waves vibrating the eardrum, or even a chemical released into the bloodstream. Importantly, it's the proximal stimulus, the event right at the boundary of the nervous system that matters. Sometimes, like with smells, the exact nature of this proximal stimulus is hard to pin down, so we might refer to the source, acknowledging uncertainty. An impulse, then, is the signal generated within the nerve fiber as a result of that stimulus. It's the electrical message traveling down the neuron. Some receptors are clever. They respond not just to the presence of a stimulus, but to changes in it, like detecting motion rather than just light intensity. A critical point: don't assume a simple one-to-one match between a type of sensation and a type of stimulus. Reality is messier. The same sensation, say, the feeling of warmth, can arise from different physical causes or different types of receptors firing. Often, it seems, multiple different stimuli hitting different kinds of receptors are needed to create a single unified sensation. Think about recognizing a face. It involves light, texture, color, all processed by different systems. Since our central problem is how the nervous system classifies these stimuli, we can't start by classifying stimuli based on how they feel. We need an independent classification, one based purely on the physical properties and effects of the stimuli themselves, as defined by physics. For example, we classify light based on its wavelength and intensity, not just because it looks yellow to us. Even the same wavelength hitting different parts of the eye might be processed slightly differently. Receptors play a gatekeeper role. They typically respond selectively to certain types of stimuli, like rods responding to low light and cones to bright light. But this selectivity isn't perfect. What we call an adequate stimulus for a receptor is usually a range of physical inputs, not a single precise value. Think of a microphone picking up a range of frequencies, not just one note. Furthermore, sometimes stimuli that aren't normally detected by a receptor can still trigger it. A classic example is getting a flash of light in your vision if you tap your eyeball hard enough, even in the dark. This shows receptors aren't foolproof. So, even before the signal reaches the brain, some sorting happens at the receptor level. This means there's no strict one-to-one mapping between the initial physical stimulus and the type of nerve impulse generated. Plus, we only register a tiny fraction of the physical energy barrage around us, like only hearing a narrow band of sound frequencies. Now we hit a historical landmark: Johannes Müller's theory of the specific energies of nerves. This was a revolutionary idea aimed squarely at dismantling the naive view that nerve impulses simply carry copies of the stimulus properties, like brightness or loudness, straight to the brain. Müller argued instead that the type of sensation produced depends entirely on which nerve fiber the impulse travels in. Red light causes impulses in the red fiber, blue light in the blue fiber, and the brain interprets the fiber type, not the light properties themselves. Brilliant! But, the text points out, Müller's phrasing "specific energy" was ambiguous. It led people down the wrong path, suggesting that maybe the impulses themselves had some inherent energy or property that corresponded to the sensation. This misinterpretation became a major dead end. This misreading was a big mistake. Assuming the impulse itself carries the secret sauce just pushes the mystery one step back. If the stimulus properties don't determine the sensation, maybe the impulse properties do? But the text argues forcefully against this. Why must the impulse properties be different? Couldn't the difference lie elsewhere? The real clue, according to this analysis, is the position of the fiber within the larger network of the nervous system. Where the fiber connects, what other fibers it synapses with, its role in the overall circuit, that's where the specificity likely comes from. There's no evidence that impulses in different fibers are physically different in any meaningful way. Even if we found such differences, it wouldn't automatically solve the problem of how they lead to different sensations. This wrong turn, fueled by the specific energy idea, led researchers down countless fruitless paths searching for elusive energies and clinging to the idea of a pure, unadulterated sensation core. The evidence actually points away from impulse differences. Experiments suggest that impulses traveling down different sensory fibers, say for vision, are remarkably similar, physically speaking. You could even cut two fibers and swap their endings, and the system would largely maintain its function. This strongly suggests that the impulse itself isn't carrying the specific instruction. Instead, the effect of the impulse, whether it produces the sensation of red or blue, must depend on the context, on the position of that fiber within the intricate architecture of the central nervous system. Think of it like this: a key might look identical, but which lock it opens depends entirely on the lock it's inserted into. The lock, the fiber's connections and role determines the outcome, not just the key, the impulse itself. So, what does this mean for our experience? It means that the qualitative differences we perceive, the difference between red and blue, loud and soft, sweet and sour, boil down to differences in the effects these stimuli or groups of stimuli produce within our nervous system. Consider how we recognize a melody played by different instruments or the same shape appearing in different colors or sizes. Our brain groups these different physical inputs together because they evoke the same underlying pattern of neural activity or lead to the same behavioral response. Conversely, the same physical vibration can feel like a sound in the ear or a tactile buzz on the skin, producing different sensations because it activates different receptor types and thus different neural pathways. The key takeaway is that the perceived quality is defined by the functional consequences of the stimulus within the organism. Let's look at some concrete examples of this complexity. The same physical vibration can be heard as sound or felt as touch. The same chemical agent can cause a sensation of light if it hits the eye, or a sensation of heat if it hits the skin. Temperature itself can feel like heat, cold, or even pain depending on which nerve endings are stimulated. Electrical stimulation is notorious for producing a bewildering array of sensations depending on where and how it's applied. And it's not just about the receptor type, context matters too. The same sound might be perceived differently if you're already focused on a visual task, or the same taste might seem altered if you've recently eaten something else. It highlights how the final sensation is a product of the entire processing chain, not just the initial input. And it works the other way too. The same basic sensation can arise from wildly different physical stimuli. If a single type of receptor is stimulated by various inputs, it generates the same kind of impulse, leading to the same basic sensation. But the real puzzle is when different stimuli, often activating different types of receptors altogether, somehow converge to produce the same perceived quality. The classic example is white light. It's not a single wavelength, it's a mixture of all visible wavelengths, yet we perceive it as a single unified white sensation. This phenomenon, where diverse physical inputs map onto a single sensory quality, seems quite common. It definitively proves there's no neat, one-to-one translation between the physical world of stimuli and the phenomenal world of sensations. The mapping is complex and many-to-many. This lack of a simple mapping extends to the very dimensions we use to describe stimuli and sensations. Physicists love linear dimensions. Wavelength increases steadily. Intensity goes up step by step. Psychologists mapping sensation often find circular dimensions, like color. Red blends into orange, then yellow, eventually looping back near violet. Or complex shapes like the octahedron for color or pyramid for touch. And the relationships are tangled. Color isn't just about wavelength, intensity plays a huge role. Tone isn't just frequency, loudness affects perceived pitch. Even more strangely, smooth changes in the physical stimulus can sometimes lead to abrupt jumps in perceived sensation, like crossing a threshold from cool to warm. Conversely, a smooth transition from cold to warm might involve switching between different types of receptors, creating a discontinuous change in the underlying physical stimulation. The structures are just not isomorphic. So, let's wrap this up. We have two distinct ways of organizing the world: the physical order, based on interactions and relationships, and the phenomenal or mental order, based on our sensory experiences and their qualities. Similarity in either order isn't about inherent properties, but about producing the same effects under specific conditions. The mind, then, is essentially this phenomenal order, this structured relational system operating within the brain. It's related to the physical order of the environment, but it's not the same thing. The big question, the central problem, is how this internal, subjective order can emerge from, and yet reflect the external, objective, physical order. How does a part of the physical system, the brain, develop this capacity to mirror aspects of the whole physical world in a way that guides adaptive behavior? How do we tackle this? The text links it directly to behavior. Things like stimulus equivalence, generalization, and transfer are all about different inputs producing the same response, highlighting the phenomenal grouping. Discrimination is about different inputs producing different responses. The entire structure of sensory qualities, the text argues, can be understood as the pattern of differences in the effects produced by different stimuli. If we can explain how the nervous system learns to respond differently to different physical input in ways that correspond to our sensory distinctions, we've explained the phenomenal order. And crucially, when we talk about effects, we mean more than just observable actions. It includes all the internal neural processes, the hidden computations happening in the brain, that mediate the relationship between the initial stimulus and the final response. The challenge is to build a bridge from known physiological elements to this complex, structured phenomenal experience.